Thank you, Tanya.
Okay.
Okay, so I'm going to take it away here on the net zero push, windows and doors. As you can see on this opening slide, we have a house that needs, we'll say some TLC when we take a look at the windows and doors. So to achieve net zero energy goals, really the selection and the installation of energy efficient windows and doors is really critical. Later, I'm going to refer to them as the energy holes in a house. In fact, not just a house, in fact, just any building. So we know windows and doors play a vital role in really determining really the energy efficiency of any building. They also can give some, we'll call it some functional personality to the look of the building. But let's move beyond that. In fact, let's even push a little bit beyond net zero, and let's just talk about windows and doors in general. Certainly, the topic of net zero, or what they call the stepped approach to improving thermal energy performance in buildings, is a very important topic these days, especially related to our changing climate. So let's take a brief look at the agenda. So we can see interactions, the impact of climate, talking about selection. We're going to take a look at some technical details and some design considerations. So when we take a look at this, we can see over to the right-hand side a capture of what we call Book 7, the net zero push related to windows and doors. I worked on that particular document with FNNBOA and also our consultants. So again, at the bottom, you can see there's a web link to our Net Zero Northern Housing on the FNNBOA website. Okay, I want to jump into, actually, let's take a look at a few things here. A couple of images. So Tanya, you're probably familiar with this house when we were up there doing some work, John Kidrowski and I. And your guys were doing some, we'll call it some maintenance and repair and some modifications to some of the housing units. So when I take a look at this, I'm looking at, we've got the Tyvek wrap, so the house wrap. We have some new windows and certainly some new siding going on this particular house. But some of the things we like to take a look at from a more critical point of view is certainly, it's nice to see that Tyvek's there, but also how will these windows be protected when it comes to other, we'll call it climatic concerns, but also environmental concerns when we take a look at any window or door. So that's what I'm really going to be focusing on.
What's going on?
So
I just moved the rig so Sam has to
So-
look right.
So as an example, is there maybe a blue skin around those windows before they were installed? Certainly, I would assume by the looks of it, the Tyvek was there because we can see the proof that it actually is there. Over to the right-hand side, we can see certainly an older window, certainly in need of replacement. So it becomes pretty obvious when we see there's a huge transition between an older window and certainly a newer window. But I think one of the key points I think that we need to take away in our discussion today is this: how well are those windows installed? And secondly, are they really a good window or a good door for that particular climate zone? So I'm going to touch on those topics a little bit in more detail. Well, I mentioned the word energy holes. It's not my term, but certainly I've come across this in a number of, we'll call it information's pieces that I've looked at. And in a way, I guess energy holes refers to the fact that a window or a door does not have the same thermal insulation value as, let's say, that exterior outside wall. So we can see in a few applications here of just some inspections that I've looked at and performed, is we see the gap at the top of the door. So air infiltration, depending on flashing, could even be water movement into the inside of the structure. Over to the right-hand side, again, we see that daylight gap at the edge of the door. So again, we take a look at these things that these are signs of actually we do have energy holes that do exist in both of these doors. Okay, sorry for the confusing looking slide here, but over to the upper left is a window. What's wrong with this window? Well, if we take a look at it, there's two little dark slots towards the top of the window. The window is actually installed upside down. Those holes should be down towards the sill because those are water drainage holes for this particular window. So again, without getting into detail of how well the window is installed, we know this particular window is installed incorrectly to begin with. If I go to the one below that, the picture below that, showing the rough wood framing, we see the gap between that nice vinyl window and the wood framing. And of course, a lot of when we talk about the installation is how well will we seal up that particular gap? Because in a lot of cases, if we simply take something like a smoke pencil, or even something like, let's say an incense stick, and we put that around the window or door, close to that opening, is there air actually going to be pushing the smoke of the pencil or that particular, we'll call it incense stick, back towards you? In other words, there's air infiltration that's happening. So again, we talk about how well a house is sealed. Jumping over to the upper right-hand side, we see a door that was installed improperly. And how can I tell? Well, not only is it poorly installed, why do we have hinges on the outside of the door? Shouldn't they be on the inside of the door? So again, potentially a lack of security. Certainly it shows that the installer did this incorrectly. Again, the lower door on the right-hand side, I'd like to look at certainly what I call the threshold, that base of the door. And of course, this is not a finish, it's a refinish of, we'll call it a house. And look at the old wood siding and of course the gaps around the door. So again, those energy holes, we like to call them or refer to them as. So the key point here is really how well is the door to begin with or the window to begin with. And certainly it's all about some installation. So let's talk about energy holes. So there's a comment by Reha. Reha, by the way, is a German window manufacturer. Windows are among the top energy consuming elements of a home. 25% of home's energy is wasted as it escapes through a flexible framework, poor sealing, and through thin glass, all of which result in ineffective insulation. So again, we're going to talk about a few points here. Windows and doors must meet today's standards based on building code. It starts with the selection of a proper insulation, selection and proper installation of the actual unit itself. But just to give you an idea, there's over 320 manufacturers of Energy Star compliant windows and doors in Canada. And again, when we take a look at them, what we should be looking at the performance requirements for your particular climate zone. Certainly a triple pane window is a magnificent window if it's affordable, but certainly with low E-film and with argon insulating in insulated spaces, they're really an excellent choice. But is it really necessary for every location? So when we take a look at it, we start talking about, let's get into a little more detail. So I mentioned, is it adapted to your climate? So windows must be designed and adapted to your climate. So when we take a look at it, Canada's divided actually into 6 climate zones, each with specific requirements for windows and doors. Products must be chosen to match your local climate for optimal energy efficiency and comfort. So one example, when we take a look at the insulation in a house, the amount of insulation required for, let's say, a wall or a roof or a foundation system, we talk about R values. So what's the R value of the insulation? Okay, so is it R12, R20, R40? So we talk about insulation in terms of this R value. So homes and buildings will require, actually, when we talk about getting back to net zero in the future of building codes, higher energy, thermal energy performance requirements in any building. So I'm going to talk a little bit more about those climate zones shortly, but again, you can see windows and doors and skylights, where the skylights may apply, account for up to 25% of the energy loss in a home. So just popping in to visit us is what I refer to as a climate zone map. So when we take a look at this map very briefly, we can see up to this portion here, they call them zone 4 through zone 8. And these are based on what they call HDDs, heating degree days. So for example, if we take a look at Victoria over to the far right of this illustration, that's zone 4. In every, it is, we'll say, based on a 3,000 heating degree days. But if I go up to, let's see, the extreme north, let's get up to, let's call it Yellowknife. It's zone 8 in 7,000 heating degree days. And when we talk about heating degree days, we're talking about the amount of extra days of heat that we have to consider when we talk about thermal insulation and insulation values. So again, basic, we'll call it basic, putting it simply, the further north we go, the colder it gets, the more insulation is required. Well, when we think about that, when we talk about windows and doors in particular, we're really talking about we really need to have windows and doors that are basically best suited for the north. So, for example, I'm down in Windsor, Ontario, just south of Toronto, and I can get away with well, we'll call it let's say a double pane window. But if I'm going to go up and live into a place like, say, Yellowknife or Churchill, certainly that triple pane window is going to make a lot more sense. It is best suited for that particular climate and climate zone. When we talk about the climate map and looking at building codes. So let's move on. Certainly making the right choice for windows and climate and aligning the project's features is an important thing that we need to think about when it comes to any build. In fact, let's not just talk about just even new building. What about replacement of existing windows and doors? Are the windows and doors that you're going to purchase best suited for that particular climate zone? We'll talk a little bit about thermal requirements for climate zones, and this is based on this particular illustration for Ontario. So we take a look at this one. The requirements vary by climate zone and by the building location. So these two slides, or actually this slide and the next one, there's one similar. We're going to take a look at in the next slide, Fort McMurray, just to give us more of a northern exposure, we'll call it. We're going to take a look at some details here. So for example, thermal requirements for climate zones, and this is produced by NEMA, okay? And they're an insulation compliance and testing organization. And based on their illustrations here, we can see over to the left-hand side, if we just take a look at exterior walls on your typical house and climate zone, southern and eastern Ontario, of less than 5,000 heating degree days, with space heating equipment with a 92% efficiency factor. So we're looking at an R22 on an exterior wall. When we look over to the one on the right, we see an exterior wall is R22 plus 5 continuous insulation performance requirements for this particular house. And this one is based on a house, for example, let's say of gas-fired versus electric. So again, the type of heating also has an impact on the amount of energy and certainly the thermal performance of the overall building structure itself. So again, we need to look at things. So for example, in Ontario, for the most part, we would be dealing with the Ontario Building Code as opposed to the National Building Code. And of course, there are differences between the two. I like to call the Ontario Building Code the National Building Code with the Ontario flavor to it. So in other words, it's more focused on the requirements for the province of Ontario. Over to Fort McMurray, we take a look at the climate zone 7B. So again, further north than that other southern Ontario slide that we saw previously. Exterior walls are R17.5. And again, depending on the type of heating system, we take a look at, is it with an HRV, heat recovery ventilation system, or without a heat recovery ventilation system? So again, even the mechanical systems or the heating systems within the house itself, along with the ventilation systems, can have an impact on the requirements when it comes to thermal performance of any particular building, in this case, a house. So let's kind of back up a little bit and take a look at pretty much, we'll call it an older home versus a newer home. So if I kind of jump over to the right-hand side, typical National Building Code house in the year of 1995 called for R12 in the walls as far as thermal insulation values, the attic of R31, the floor R28, the foundation R10, the windows R2, and the doors R2. Well, current codes call for that to be in the walls of R22. You can see a substantial increase in the walls. Look at the attic, again, a substantial increase, R50 to R60, floors R31, and again, the foundation R20. And let's also take a look at our main topic here about windows and doors. So for example, even the windows and doors have basically doubled, and in some cases almost tripled in the requirements when it comes to thermal performance requirements. Therefore, a highly insulated and air-sealed building envelope is certainly a must. So when we take a look at these, we can see there's been a substantial change. So even a house that's 15 years old, or let's say even 20 years old, but even as recent as 15 years, there's been a significant change in the requirements for thermal performance. So we're going to boil that back down to beyond just we'll call it the building itself, certainly back to windows and doors, which is again our main topic here. So again, just another look at insulation and climate zones. So for example, this was compiled by John Eakes, National Building Code 1997, different zones, A, B, C, and D. And if you look at zone A, was Vancouver Island. And zone B, sort of, we'll call it lower British Columbia, B. C, jumping over to, we'll call it, this is going to be in Saskatchewan. And then D, looking at northern Saskatchewan. So we can see by just simply this old chart, the recommended insulation levels back in 1997. And certainly these things are sort of, we could take a look at it, that most houses today are inadequate when it comes to the thermal performance, we'll call it ratings, that are basically required today. Again, we see our climatic zone maps. So again, we can see that for the most part, that green area, the northern extreme, that's where the most, we'll call it highest insulation values are required. So let's get back to some windows and doors. So when we take a look at this particular slide, we're talking about R values, okay? So R value equals 1 U value. So when we start talking about dealing with building codes, you will encounter what's called a U value versus the older common term we used to refer to as, well, I guess we still refer to, I like to refer to my old school thinking of R value. So we can see in this particular area showing the windows depictions that a basic single pane has an R value of 1 and a U value of 1.0. And a standard double pane if we take a look at it, are 2.5 or a U value of 0.40. A high performance double is going to be taking a look at R4 in a U value of 0.25. In a triple pane, R6 in a U value of 0.17. So what are some of the key takeaways that we take a look at here? Well, we know that probably if you're from the old school, we'll call it, as opposed to talking about U values, we can see that as the R values increase, the performance also, thermal values have also increased. Remember, we're talking about R12 or R20, or in some cases, much more insulation in a wall. Okay, so when we start even taking a look at the illustration over to the right-hand side of this sort of isometric view of a wall section, we can see that we have an R12 insulation in the wall. So if I go up over here, this insulation's R12, but there's also an effective thermal resistance value of R16.7. And this is built up because of the various layers and insulation values for this particular wall assembly. So we take a look at gypsum board, the vapor barrier, the insulation. It's on a 2x4 wall framing system. It has expanded polystyrene, okay, so rigid board insulation nailed to the stud. It has a sheathing membrane or an air barrier, and of course siding. So again, we won't get into all the details of effective versus just the general insulation values of this particular wall for the R values. But R values measures resistance to heat flow commonly for different materials such as insulation. U values are being used to measure heat flow itself, heat transfer through a window or through a particular opening such as a door. So again, the source of R value can be explained. Again, I've got a web link there. And if, by the way, later, if you just drop me an email or drop FNNBOA an email, we can give you more information about these R values. So basically what we're looking at, the higher the R value, the better the insulation factor. The lower the R value means more heat loss. When we talk about U values, it's the opposite. You'll notice that, for example, the U value started at 1.0 over here for the single pane. But when we get over to the ones in the middle here, notice that they're dropping 0.40, 0.25, in a triple pane, 0.17. So again, one of the things that we need to be aware of is what are those factors and how does it equate to how do I get better thermal performance? Oops. Didn't want to go there. Oops, what happened here? Did I lose you guys? There we go. Come on, just
You're still here, Claude, but sometimes it muffles out. I'm not sure if it's the
if it's me or
yeah. There's nothing here. I'm looking. It might be like if you're close to the mic.
I'm reasonably close to the mic.
Okay. Well, we'll keep going.
Okay, let me just go back a minute here. A couple slides. I just want to make sure I was going in the right direction. Okay.
Perfect.
Okay, so selection of new builds and retrofits. So when we talk about window or doors, we must consider a number of factors, as I pretty much have been talking about so far. So the National Energy Code of Canada for buildings of 2020 and the National Building Code of Canada 2020 set the requirements for windows indoors. But not only that, certainly construction of buildings in general. But when we start talking about energy codes, we also need to think about the requirements are changing as we talk about, net zero, and certainly we talk about the changing climate. So these codes basically provide the current standards and recommendations for energy efficiency in the building components. They perform are basically specify the minimum performance standards for air tightness and durability. So when we're out looking for windows and doors, there's a couple of things we should be looking for. And we should be looking for those that are ENERGY STAR certified, and certainly those that are suitable for your particular climate zone. So ENERGY STAR products are independently tested and verified to meet the strict energy efficiency criteria. Basically, that is in the building code. When it comes to windows in a new build, the total area of windows for that exterior wall of a house is recommended to be no more than 25% of the wall area. In fact, in some cases, if you really want to do better, certainly at 25% is probably, we'll call it the higher end of the amount of openings in any wall system, as opposed to, I've seen some in the range of 15 to 17 to 18%. So again, the larger windows certainly mean more heat loss through those openings. And it's not just the heat loss. We also talk about, what about the air infiltration, that cold air coming in from outside. So we think about things like that. When we talk about selection, certainly we need to at least meet the building codes. So let's take a quick glance at a few of the issues that are mentioned in the building code. So again, on this slide, 2020 NBC windows and doors and skylights. This is just a screen capture of what's in 9.7 of the National Building Code. It talks about windows, doors, and skylights. So I've kind of shown you, when we talk about the language of building code, they talk about a subsection. So subsection 973 talks about the performance of windows, doors, and skylights. So you can see up here, this is sort of the index 973. In the article 9731, general performance expectations. And we get down to what they call the sentence level. And it says, as provided in sentences 2 to 4, windows, doors, and skylights and their components, separating conditioned space from unconditioned spaces or their exterior shall be designed, constructed, and installed so that when in the closed position, they A, resist the ingress of precipitation, resist wind loads, control air leakage, resist the ingress of insects and vermin, where required, resist force entry, and are easily operable when not intended to be fixed. So those are basically testing performance requirements that any window manufacturer that's going to do a tested assembly for a window or a door must meet. Well, really, when we think about that, that's also what we are anticipating that should be installed on any particular, we'll call it house, or any particular building. Part 9 of the building code really is for, we'll call it primarily for residential, or we'll call it smaller buildings, whereas opposed to part 3 gets into the larger projects, larger buildings. So again, some of those key things, as we can see there, I've highlighted with that, we'll call it burgundy rectangular box. These are some of the features. And of course, there's notes when we talk about building code. But I'm not here to teach you all about building code, but just say these are the minimum building requirements when we take a look at things such as windows and doors. We also can move on, and it talks about windows, doors, skylights, with or without storm doors. We're looking for certain maximum U values and minimum temperature index. So we take a look at, for example, what they call the design temperatures. These are our winter temperatures, warmer than -15 Celsius, between 15 Celsius and -30, and colder than -30. We can see that the windows and doors have certain performance criteria that we should be looking for. So these are basically reference numbers. So for example, 2.5 versus 1.7. Well, what this kind of tells us is that in a warmer climate, we don't need quite as high a thermal performance value as the colder region, for example, 1.7. So again, the U values for specific products can be determined by the window manufacturer or the CSA standards, okay, for North American Fenestration standard specifications for windows and doors and skylights. So again, these things tell us about the minimum temperature index. So the minimum index indicates the product's ability to resist potential for condensation. So again, potential for condensation to occur versus a colder climate. So again, these are all tested assemblies, and these are the performance requirements that should be met when we talk about the selection of windows and doors. We can also move on a little bit and talk about also that heating degree days based on building location. So for example, we see the 6 zones here, zone 4, 5, 6, 7A, 7B, and 8. And again, the performance requirements. So as an example, if we take a look at a window, let's say for Whitehorse, it probably is going to, not probably, it does require an R value of roughly the equivalent of an insulation value of R4. Okay. When we take a look at one, let's say for zone 4, more down in my neck of the woods, an R3. Okay, so again, these are current 2020 standards. And again, by the way, things are going to get a lot more higher when it comes to thermal performance requirements in the upcoming future. So for example, the 2025 building code, how about the 2030 building code, and so on and so on, because the further along we get, the more, we'll call it thermal efficient our buildings must become. Air leakage. Well, back to those windows we saw and doors we saw earlier in those slides, right from the very, very beginning, we saw those large, huge gaps around windows. So when they frame a window, typically in the frame, when they do the rough framing, there's usually about a ½ inch of clay, we'll call it, around the framing to allow for the fitment of windows and doors. So again, to fit them, but the question is, how well are they sealed when we talk about the actual gap or the opening around that particular unit that's going to be installed? So again, when we take a look at the building code, they talk about in section 936, which is all about energy efficiency. And in this particular part of the building code, air tightness, we're talking about how well are we going to be required to seal up those openings. So again, the building code pretty much tells us that when we take a look at these things, when we talk about windows and doors, not only do we have to think about what we're going to select, but how well are we going to install those things, those issues such as windows and doors when we get on site. So let's do a little, we'll call it backing up and take a look at sort of we'll call it the components of a triple glazed window. So a triple glazed window refers to a window with 3 panes of glass. We can see here in this illustration. Low E refers to low emissivity, minimizing solar heat gain. So when we talk about that solar heat gain, we have to think about in the summer, that heat gain coming in from the solar effect through the windows, heating the inside of our house. Certainly in my particular area, if I don't have a low E coating on my windows, I'm getting a lot of heat gain inside the house. And in my case, I also have to live in the summer with running air conditioning. Get rid of some of that heat that's building up in the house. That can be a good thing in a northern climate when we're trying to offset the cold days, but not necessarily a thing that we need to always forgo, because low E refers to minimizing that solar heat gain. Argon gas, being a colorless gas, it's denser than air and acts as an insulator. So basically, within the panels of glass, they are filled with argon gas, which basically acts as an insulator in between the glass. So again, the low E coating is a sturdy window frame. Again, we know there's all different types of products out there, be it wood, vinyl, fiberglass, metal, and so on when it comes to the actual frame itself. So that actual frame itself. So again, just trying to give us some idea of just sort of the components. These gray areas that look like they have little bubbles are basically foam gaskets in most cases. that are really thermal breaks, so that when the outside of the glass gets cold, it doesn't necessarily transfer the cold to the next pane, or the heat from the inside of the house going in the opposite direction. So let's compare a triple to a double glaze. So we'll keep it pretty simple. Well, if we take the bottom line, the cost difference can range upwards of 30% or more for a triple glaze window. But here are some of the summary tables, the features. The insulation is excellent on a triple glaze, energy efficiency superior, condensation control is excellent, noise reduction excellent, and the cost certainly is higher. Certainly nothing wrong with a double glaze window. All my windows are double glaze. I don't necessarily need triple glaze, although if I was going to replace all the windows on the north side of the house, I probably would consider going triple glaze for those windows, because that's always going to be the coldest side when it comes to, we'll call it heat loss, lack of sunshine on that particular north side of the house. Next, let's talk a little bit about Energy Star rating. So when we take a look at Energy Star rating, it's an internationally recognized certification program that basically identifies products meeting their strict energy efficiency standards. So one of the first things we should be looking for is certainly that Energy Star, we'll call it label on a window. Again, it identifies here the spacer, the gas, the low E coating, the triple glazing. But this means a product's been independently tested and certified, and it meets a particular standard. But what we really need to do is next go beyond just thinking about the Energy Star rating, is taking a look at the label. The label on windows. So again, when we were doing some training out in Winnipeg, we were visiting a local called lumber yard, and we were looking at a number of different windows, and you take a look at the energy rating, the Energy Star labels. So first off, what are some of the key things that we should be looking for when we take a look at that Energy Star label? Well, the U value, that's a building code issue, smaller number, lower heat loss. So 1.10 for this particular window. The energy rating, okay, is 36. The larger number, higher the energy efficiency rating. Another part, we talked about air leakage. Well, the air leakage number less than infiltration. We can see it talks about the air infiltration. Who makes a window? And of course, this one is a CSA standard certified, that tested for meeting their assurance testing standards. Over on the other side, we have solar heat gain, visible transmittance of light that passes through the window, and the condensation resistance. So again, we take a look at this particular window as being probably pretty good for a particular area, so meeting a particular climate zone. But we'll notice that at the lower part here, in 2025, if we take a look at this particular U factor here, it's 1.10. 2025, we're already in 26 currently. To 27, the expected Energy Star max U factor is to be 1.05. So currently, this window does not meet today's standard, or an energy rating of 40. Again, didn't meet it. So again, we could tell this particular window, if this was a new build today, does not meet the current building standards when we talk about building code. Let's take a look for the future. 2030 is expected to be a factor of 0.82 and an energy rating of 44. So again, when we start taking a look at the labels, we have to understand where are we today and what are the targets we should be looking for. Now, again, these numbers are going to vary, and of course, based on the actual requirements for your particular climate zone. Let's jump into next, talking a little bit, moving beyond the label. What about the installation? Well, this illustration kind of gives us a window flashing diagram. Install flashing from the bottom up. Okay, so in this particular case, we can see step one, the sill flashing turns up. So for example, if we imagine this as being our Tyvek, this gray area here, and if we start looking at some of the wraps to basically flash this window better, tighter, to reduce not just air, but also water, moisture coming through this window, we want to take a look at tightening up and sealing these openings better. We saw again earlier those great big gaps, which we don't always know how well they've been filled, how well they've been insulated, even if they were insulated or not. There could be a number of concerns, certainly, when we know that there's air leakage around any window or door. So how do we tighten it up? And this is what this insulation detail is all about. Well, we can see there's jam flashings to the window units installed. There's a head flashing, and certainly there's a flash termination. So, for example, what we need to look at is how well these windows can be installed. So these are all important details when it comes to window installation. And we could say basically in a similar fashion, well, same thing pretty much is recorded for the door. So these are a couple of illustrations I borrowed from our Arctic modeling window installation details. So for example, if we take a look at where I've bolded and red the self-adhered flashing tape, this purplish color. So this is sort of up at we'll call it the head or the top of the window, and also at the base, at the sill of the window. And they talk about, so for example, these flashings, this tape. What are they talking about when they talk about these tapes and flashing? Well, what they're really talking about is two products that are pretty common in the market today. Tyvek, which is a house wrap, versus Blueskin. What's the difference between the two? They're both great products. So when it comes to windows and doors, Tyvek and Blueskin depends on a specific project and local conditions. So again, I've kind of put on this slide some of the key features. So Tyvek, known for its breathable nature, allows moisture vapor to escape while blocking air and water infiltration. It's favored for its versatility and wide availability, making it popular for many homeowners. Blueskin, a little more expensive. And what it is a thicker flashing membrane that provides a continuous air barrier, which helps maintain indoor comfort. It's designed for extreme weather conditions. Keyword here, extreme weather conditions, offering superior moisture management. Good product, great product. Certainly there's a cost difference. Blueskin is primarily made from a self-adhering membrane. Both house wraps serve as critical role in energy efficiency. So again, when we take a look at this, are those being used when a window or door is being installed? So as an example, I had two of my back windows replaced. And again, the installers, basically Tyvek, over top of that, Blueskin. No problems. Great products. A little bit about door installation, shims positioned. So again, we can see this gap, so to speak, this greenish color around the door frame. So the rough framing in brown or brownish color is representing the wood framing around the door opening. We had some shims or some blockings in place to help especially strengthen around where the hinges are and where the latch is. But we've got this whole green space that we have to basically fill. And is that being filled is an important detail. So low expanding foam insulation applied between the jamb and the house frame, seal up that gap, that opening. We can see here a couple of images where we can see kind of the Tyvek. We can see the flashing going in around these windows, and of course caulking and sealing in this particular case or this particular door sill. So a sealant applied beneath the door sill, so sealing it, because sometimes the installers just don't do that. It's just fastened to the floor or tight to the floor. Moving on, considerations. Again, we see our map here, our climate map. Careful consideration must be given to your geographical location where the window or door will be installed. One cannot assume that a window or door based on a southern location such as Toronto or Vancouver can actually fulfill the same performance requirements, say, for Edmonton. So again, we've done a comparison in our net zero study, how you can see here, when we talk about the maximum U values, the energy ratings, and so on, based on building code. So again, just talking about that in general, you can see that we need to look at the consideration. Again, we can't take that window from down here. Well, you actually can take it and move it up north and install it. But what's going to happen is exactly, will it serve the thermal performance value, or you're going to always have a lot of heat loss through your windows and energy just being wasted. I think I might have jumped ahead here. Yes, I did. Okay. So again, we analyze that window label. So for example, if we kind of use this as kind of an example here, we can see U value is 1.2 over here, or if I want to compare it to insulation, R 4.7. It's better than the R value than code requirements, is good for region 7B and 8. However, note the ER is 25, and the energy rating for that particular zone really requires an energy rating that is a better value. So the required value is 29 for zone 7B and 8. So we would have to go into the building code and take a look and compare this of what's required by code today versus, well, let's say, the performance standards for the window being installed today. So for example, again, we have, it's been energy verified. This happens to be a classic double hung window, a wood frame, it's metal clad, and it's triple glazed, by the way. So again, this is a double hung window having a middle frame, this particular, okay? Yeah, but again, is this window good for your particular climate zone for your install? So again, we take a look at this. The higher the ER, the more energy efficient the product. Insulated steel doors, again, look for the following characteristics. Strong rigid polyurethane core, number one. It is a solid core. All exterior doors should be at least solid core or at least rigid polyurethane. Weather stripping. So again, we take a look for the weather stripping. Adjustable threshold, this threshold here. Steel construction, both inner and outer door skins, so the metal. Adjustable hinges, again, to ensure proper alignment and seal. Like windows with proper sealing at the perimeter, as well as any required flashings. So what do we need to look for when planning for window selections? Well, do we need to have triple pane insulated glass units and quad pane for high efficiency homes? More than one low E coating. Look for argon gas between the panes of glass. Warm edge spacer. So warm edge spacer are typically anything but metal, so not aluminum. Frames made of non-conductive material, so for example, wood, vinyl, or fiberglass. Vinyl is the most common and cost-effective. Fiberglass is a great window, but a little more expensive than vinyl. U value and ER rating will be specified in the code or better for the heating degree days for your particular climate zone. Subsequently, the product label on the delivered window or door will bear the mark of the certification agency, confirming the U values and the energy rating. So before closing, a few other just general considerations. My backgrounds are architecture, design, and construction. When I take a look at a window or door, we talk about thinking about solar orientation. When we talk about solar orientation, ideally designing larger windows that face south, utilizing smaller windows when they face north. Consideration of an entry vestibule, again, to cut down on heat loss. It's almost like we'll call it a double lock door system, where basically you almost have that, we'll call it little push out at the main entrance door to cut down on heat loss. Considering wood blocks, or wind blocks rather, natural features such as trees and bushes. And north, what about a windbreak tree cover to help block the cold winter winds? So again, these are just a few general, we'll call it architectural or construction design considerations when we talk about windows and doors. Certainly, this would also not just have an impact on windows and doors, but also the thermal efficiency of the building structure itself. Certainly, a few other considerations when we talk about windows and doors is the issue of security. Egress, being able to get in and out comfortably. Safety, window guards, is there safety glazing? There's limits on how much a window can open on a second story. So for example, in the building code, they talk about window fall protection. Is the windows too low to the floor area? We also need to think about moisture and condensation issues and accessibility. So I've seen some plans that show just one door, and that's minimum standard. And I've seen some good plans that also show a front and a back door, a second exit. Maximum height of door threshold should be no more than 3/4 of an inch. So again, because we think about accessibility, people in, say, wheelchairs. So again, some final takeaways. Windows and doors do not consume energy. They can be a significant source of heat loss in a home. They must be properly installed and well sealed. Ideally, the total area of a window for an exterior wall of a house is recommended to be no more than 17 to 20%. I said earlier, 25%. And what we're trying to do is, we'll call it shrink down the size of windows, because they are the major areas where we may gain heat in the summer, but we certainly lose a lot of heat in the cold weather. So again, poor insulation values, at least by today's standards for the most part. Our stats data indicate that a significant number of existing window types as just simply standard double pane units, and the age of those windows are often more than 16 years of age or more. Thus, the importance of upgrading and retrofitting existing households to achieve a net zero ready compliance level. Consider total costs rather than the initial building cheaper, we'll call it first costs. It's really about efficiency and performance. I want to thank you. Hopefully you take something away from this. Need more information, go to our FNNBOA website. We do a series on net zero housing for Northern Indigenous communities and technical guides that we've worked on, so we can learn more about it. And if you're looking for more housing resources, certainly we have a large housing resource section. It's ever growing, ever expanding. So again, I'd like to take the time to thank you, and certainly if you have any questions, I think we have maybe a couple of minutes.
Yeah, Claude, we have Lisa has a question.
Yes. Go ahead, Lisa. Lisa still there?
Yeah, looks like she is. We don't hear her.
Was it posted by chance?
So, sorry?
Oh, okay. Lisa, is there time you can describe requirements for a basement egress window, not just the size? Yeah, Lisa raises a very good question. Can you describe requirements for a basement window, egress window, not just the size requirements? I typically, when I do home inspections or inspections of housing, take a look at what is the size of the windows, if any, particularly in a basement. And more so if it's an issue where I know it's going to be a sleeping space, or people are going to be sleeping in the basement. Because one of the issues, certainly when we talk about fire, is the issue of what's the exit path or means of egress to get from the basement out of the house. And typically, I would say in a basement situation, it's up a set of stairs, some pathway through the house to the outside door. So what really Lisa is getting at is that when we talk about basement egress windows, we really want to talk about how can we safely exit as a second means of exit out of that space. I have seen cases where the windows are too small, they're too high above the floor. You'd almost need a ladder to get to the window. And of course, there are egress window requirements when it comes to the actual size and distance from the floor to the sill of the window and the actual size of the window that the person can safely exit out of. So again, certainly we talk about basement egress. I have in my inspection practices seen situations where you see sleeping space in the basement where there's been an issue where I would flag in my inspection report that it would be a safety concern. In other words, a significant issue. So Lisa, that's a really good question because you have to think about how can a person exit safely in case of a fire. So thank you for your question, Lisa. I hope I've answered that for you. Not so much about the energy efficiency, but certainly we have to think about the path of safe exit to basically get out of the basement in case of an issue such as a fire. And then, of course, not being able to get back up that stairway to safely exit. Again, you were thinking of mechanism. When we talk about mechanism, I take a look at, again, is it basically the access to basically climb to the window or exit safe? We need clearance on the outside. So certainly I look for things such as a window well. And certainly thinking about window well, we know that water and snow and rain can accumulate in that area. So we think about drainage, but also is can a person safely get out through that particular window opening, particularly in a basement? Both, and if it's a slider or a crank. I would say a slider. A crank can work, but I would say most of the ones I've often seen tend to be sliders. So again, the building code basically specifies I'm just watching Lisa typing. Sorry. Okay. Yeah. Certainly both a slider or a crank will work. The idea is, can a human body safely get out through that window? So we when we get into the actual code size, is not just the size requirements. It's certainly, can you safely exit out through that particular style of window? Thank you for your question, Lisa. Greatly appreciated. Sorry if I am breaking up on you. Any other questions before we move on?
Well, I think that's it. Claude, great job.
Well, thank you very much.
Thank you
Uh,
everyone for joining.
Yeah, and feel free to drop me an email. If you care, if you have any other questions, I'm not going to claim to be an expert on all of this, but certainly know enough to at least pass on the message. So again, thank you very much. And hopefully you tune into some of our other upcoming, we'll call it webinars.
Perfect. So I'm going to stop recording here, Claude.
Thank you very much. Have a great day.
You as well. Thank you. Great job, Claude.
Cheers.
Thank you.
Thank you.